Here is a question that sounds simple. If we took every engineer, every construction company, every piece of modern machinery on Earth and gave them unlimited money, unlimited workers, and unlimited time, could we build the Great Pyramid of Giza today? You would think the answer is obviously yes. We have cranes that can lift thousands of tons. We have lasers for precision measurement. We have computers that can calculate structural load to the millimeter. We have explosives, diamond-tipped drills, and GPS satellites. The ancient Egyptians had none of this. And yet, when the world's top engineers and architects actually studied this question seriously, the answer they came back with shocked everyone. We cannot build the Great Pyramid today. Not the way it was built. Not with the same precision. Not with the same materials. And possibly not at all. Welcome back to the hidden archive where history hides its secrets. Today we are going to ancient Egypt to ask one of the most fascinating questions in all of engineering: why is the most famous building in human history also the one we cannot replicate? Subscribe if you're new. A new mystery every week. Let's get into it. Before we get to why we can't rebuild it, let's understand what we would actually be trying to rebuild. The Great Pyramid of Giza was completed around 2560 BC, making it approximately 4,500 years old. It was the tallest structure on Earth for over 3,800 years, a record that wasn't broken until the Eiffel Tower was completed in 1889. The numbers are staggering. The pyramid contains approximately 2.3 million stone blocks. Each block weighs on average between 2.5 and 15 tons. Some blocks in the interior, particularly in the King's Chamber, weigh up to 80 tons. The base of the pyramid covers an area of 53,000 square meters, roughly the size of 10 football fields. It is level to within just 2.1 centimeters across its entire base, an area the size of 10 football fields flat to within 2 centimeters. The four sides are oriented to true north, south, east, and west with an accuracy of less than 0.05 degrees of error. These measurements were achieved by people using copper tools, wooden sledges, and ropes made from plant fiber. Without steel. Without motors. Without computers. Without any technology we would recognize today. And when modern engineers try to replicate even individual components of this achievement, they run into problems that our most advanced technology cannot easily solve. Let's start with the most fundamental challenge: precision. The base of the Great Pyramid is level to within 2.1 centimeters. To put that in perspective, that is the precision of a modern Olympic swimming pool. It is extraordinary accuracy for any construction project today. For a structure built 4,500 years ago across an area of 53,000 square meters, it is almost impossible to explain. Modern engineers who have studied this say that achieving this level of precision today, over that area, using any method would require GPS satellite surveying, laser leveling equipment, and teams of specialized surveyors working continuously. The Egyptians achieved it using sighting instruments made of wood and string. How, we genuinely don't know. Then there is the stone fitting. The limestone casing blocks that once covered the entire pyramid, most of which were removed in the Middle Ages to build Cairo, were fitted together so precisely that you cannot insert a piece of paper between them. A blade of paper. Between two 2.5-ton limestone blocks, cut and placed 4,500 years ago. Modern stonemasons who have attempted to replicate this fitting using the best diamond-tipped saws and grinding equipment available today have not been able to match it consistently. The ancient Egyptians did it with copper chisels. Now let's talk about the weight. The pyramid contains an estimated 5.75 million tons of stone. Moving that stone from quarries some located hundreds of kilometers away and lifting it into position is the engineering challenge that has puzzled experts for generations. The heaviest blocks are in the King's Chamber granite beams weighing up to 80 tons each. These blocks were quarried in Aswan, approximately 900 kilometers south of Giza, and transported by river and then overland to the pyramid site. Today, moving an 80-ton block would require a specialized heavy transport vehicle, the kind used to move industrial machinery or military equipment. These vehicles cost millions of dollars, require specially reinforced roads, and move at walking pace. The ancient Egyptians moved dozens of these blocks. But the lifting is where it gets truly difficult. The King's Chamber sits 43 meters above ground level, roughly the height of a 14-story building. Getting an 80-ton granite block up there, into a precisely measured space, without modern cranes, engineers have been arguing about how this was done for over 200 years. And here is the uncomfortable truth: no one has successfully demonstrated a method that fully works. Theories include internal ramps, external ramps, water lubrication, and even counterweight systems. But when engineers build scale models and test them, each theory has a problem that the evidence doesn't fully resolve. The most honest answer from the engineering community is, we don't fully understand how they did it. Here is a problem that most people never consider. Even if we could solve the precision problem and the weight problem, we may not be able to find the materials. The Great Pyramid used two types of stone: local limestone for the bulk of the structure, and raw limestone for the precision-fitted casing blocks. The two raw limestone quarries near Cairo were largely exhausted during the Middle Ages when the casing blocks were stripped from the pyramid. The granite for the interior chambers came from Aswan. This granite is still available, but the specific type and quality used in the pyramid, quarried from specific locations, may no longer exist in sufficient quantities. And then there is the mortar. The ancient Egyptians used a mortar between the core blocks, a substance that has been analyzed extensively. It contains a mixture of gypsum, sand, water, and organic material. It is still chemically bonding after 4,500 years. Modern chemists have analyzed this mortar and cannot fully replicate its composition. The organic components appear to have come from specific plant sources that no longer exist in the region in the same form. We can approximate it, but we cannot recreate it exactly. And finally, even if we solved all of the above, there is the workforce problem. Modern estimates suggest the pyramid was built by a workforce of between 20,000 and 30,000 skilled workers over approximately 20 years. These were not slaves. Archaeological evidence has conclusively shown they were paid, fed, given medical care, and buried with honors near the pyramid site. They were specialists. Stonemasons who spent their entire lives developing skills specific to this project. Skills passed down through generations. Skills that were refined over decades of continuous practice on the pyramid itself. Today, there are virtually no stonemasons in the world with experience cutting and fitting limestone blocks to this precision at this scale. The craft essentially died out centuries ago. Even if we recruited every stonemason in the world, they would spend years simply learning the techniques before they could begin to approach the precision the ancient Egyptians achieved routinely. Here is the twist that changes everything. We have been asking the wrong question. The real mystery is not whether we can rebuild the pyramid today. The real mystery is how did a civilization with no steel, no motors, no computers, and no modern mathematics manage to build something that our most advanced technology struggles to replicate, because the implication is unsettling. Either the ancient Egyptians possessed knowledge and techniques that have been completely lost to history, sophisticated engineering methods we have never discovered or rediscovered. Or, and this is what some serious researchers now believe, the civilization that built the pyramid was more technologically advanced than we currently understand. Not in the way of science fiction. but in the way of practical engineering knowledge accumulated over centuries of careful observation and refinement that was simply never written down in a form that survived. We know more about ancient Rome than about the engineers who built the Great Pyramid. We have their structure. We have their precision. We have their mathematics encoded in the dimensions. But we do not have their manual, and without it the greatest engineering achievement in human history remains, after 4,500 years, genuinely beyond our full ability to explain or replicate. The Great Pyramid of Giza is not just the oldest of the 7 wonders of the ancient world. It is the only one still standing. And perhaps the most remarkable thing about it is not its age, or its size, or even its precision. It is the fact that 4,500 years later, with all of our technology, all of our engineering knowledge, and all of our resources, we look at it and still cannot say with complete certainty, here is exactly how they did it. That is the real wonder of the Great Pyramid. What do you think? Did the ancient Egyptians have knowledge we've lost forever? Leave your theory in the comments. Subscribe to